Hello and welcome to another video about the fundamentals of math from brilliant.org. So the whole point of today's video and this series of video is to look at the mathematics, especially the fundamental of mathematics, like the arithmetic, the algebra, logic, and number theory, to build this solid foundation. So when it comes to solve problems for clients using software, I can do that in a much more fast way, and also be able to explain that and mention the source where my knowledge base or my knowledge tree comes from, so we can have on the same page. And also it builds trust, because at the end of the day, the whole point of not only solve someone else's problems is to build trust also and make it sustainable. That's the whole point of this. Okay, that's the goal. So for that, then I decide to look at the fundamentals of mathematics from brilliant.org. So Brilliant is a company co-founded by, let me take a look at this. So it's a company co-founded by Soo Kim in 2012. So he presented the idea to angel investors and venture capitalists in Chamat Palihapitiya. He was a senior executive at Facebook from 2007 to 2011. So he invests in this idea from Soo Kim, and then also creates a fund called Social Capital, where he invests in companies like Jammer and Slack. So, looking at the mathematical fundamental, as I mentioned before, here we're gonna learn essential tools for mastering algebra, understand what algebra means, arithmetic as well, and the concept of mathematics, where mathema, or this mathematic, comes from. What is the etymology of mathematics? All right, and also the logic and number theory. So the first model I look at what the mathematic is all about, which is it's all about understanding why patterns emerge. And you may wonder, yeah, but where? What is the context? So mathematics, the etymology of that comes from the Greek word comes mathema, and mathema, it means what one gets to know. And this is something beautiful, because this is not something that we come from this, but this is something that we can aspire to. And that's beautiful, especially if you're building your life to understand where you are. So mathematics right now is the application of all of this set of principles and guidelines, and especially mathematics mean is those who apply those activities, those who apply is things that once you get to know, all right, and understand now what is the main value proposition with the generalized, which is in this course we're gonna look is patterns about we're gonna look at the arithmetic. So we're gonna look at certain patterns in arithmetics and how we can use those patterns to create generalizations, general guidelines using algebra. So because in math, especially when you get to know something in your life, it's very, very rare that only present just once. So here we look at how can we, for example, uh, looking at specific problems on the math, which is what is the sum of the odd numbers? What is the result of what is the sum of the first n odd numbers? Okay, so for example, 1 plus 3 plus 5 plus 7, you know. So what is the sum of all of these odd numbers? And how we can, by using some visualizations, how we can infer and understand why this pattern occurs, and by using algebra we can is represent a formula, so we don't have to calculate that for ourselves, meaning we save time to do that computation. So that's great, all right? Because I also look at how can I create is this generalization, especially when it comes to find the result of, or find the sum of all, find the sum of the first n even numbers, all right? So the formula or this generalization is, if you want to know what is the sum of all of the, so if you want to know the sum of the first n odd numbers, use the n power 2. All right. So for example, if you want to know is calculator. Okay. So if you want to know is what is the sum of the first 7 odd numbers, like 1. So instead of doing this, come on. So instead of doing uh, can you, okay, 1 plus 3 plus 5, okay, plus 7 plus 9 plus 11. So instead of doing this calculation, we want to know is the first 6. We want to know is the sum of the first 6 and of the first 6 odd numbers. So instead of doing this calculation for ourselves, okay, we can just say is n, which is the number of the numbers we want to calculate, n power 2, meaning multiply by itself, and you get that. So if you want to know now the sum of the first n even numbers, so the formula change, which is n power 2 plus 1. So for example, if you want to now calculate is the first 6 odd numbers plus 4 plus 6, god damn it, 6 plus 8 plus 10 plus 12, right? The first 6 even numbers. So instead of doing this, all right, yeah, this is the 3, 6, like this. The formula here, which is something that I define here, exactly. So the formula here is, well, n power n, or in this case 6 per 6, plus the number of the number, the even number, which is 6, and we get this. So the whole point of looking at this, and this is funny because it's 42 the answer, Anyways, so the whole point of looking at this is that generalize in mathematics, and especially the value proposition of the mathematic is that it allows you to understand why patterns arise. So that's all about mathematics. So with this set of tools that we're going to learn here, we just want to recognize is when this particular patterns happens, we know what we have to do. Okay, so in other words, by looking at the way of how you can calculate each one of them, or by looking at specific patterns to solve specific problems, how you can generalize so you can have this as your toolkit. Much like when you have a League of Legends or Fortnite character, you add skills, so you add spell. That's the whole point of this. So you add spell to them. All right, cool, cool. So now that I look at this, at the generalized, and also it was interesting how we can, by using visualizations, we understand this particular pattern. And again, according to brilliant.org, the whole point of this is, or the mathematic, is to understand why patterns arise. Cool, cool. That's right. So, so yeah, that's the value proposition of mathematics. So the practice of trying to generalize a lesson. Okay, so anytime you see a particular problem, and the practice of generalize a lesson, you learn. So the practice of trying to generalize a lesson you learn is the core of mathematics. So the core of mathematics is to understand, or math is all about understanding why patterns arise, and it is the practice of trying to generalize a lesson, trying to generalize something that you have learned. Very, very important here. Okay, so that's something interesting. I also understand that arithmetic comes from the Greek word arithmos. That arithmos is mean count, and arithmetike from the Greek, it means the art of counting. And now, looking at for this particular lessons, how looking patterns when it comes to counting or doing this arithmetical operation, these operations that you do on numbers like addition, the subtractions, divisions, multiplications. So look at the patterns, and from there see what generalization, what general rules you can extract from this and use algebra to describe it. Why? The TLDR is to avoid some time expense in computation and understand why this pattern arises. All right, so now I'm going to take a look at the rewrite, rethink, and redraw here, which is this continue lesson. So in this section, we're gonna explore a fractal pattern and a compound interest in the mathematics of fraction. Two key concepts here. Okay, so explore fractal patterns and compound interest in the mathematics of fraction. Okay, so first things first, what is a fractal pattern? Okay, because in this course we're going to learn is this two concepts here. So visualize fractions less than 1, and we'll learn about beautiful mathematical pattern called fractals. And while fractions greater than 1 will reveal the exponential growth of compound interest. Okay, there are several things here. So first is fractals. Explore fractal patterns and compound interest in the mathematics of fractions. So far, the previous lesson we will explore is the patterns the first lesson we explore is the patterns, or particularly patterns that arise in arithmetic, okay? In how, by looking at this pattern, how we can generalize, or how can we solve general principles and use algebra to describe them. Here we're gonna take a look at the mathematics of fractions. So by exploring is fractal patterns and compound interest. All right. Okay. So exploring fractal patterns and compound interest. So this course is all about learning to see math in a new way. So by visualizing fractions less than 1, we'll learn about beautiful mathematical pattern called fractals. And while fractions greater exactly. Again, so we explore here fractals and compound interest, but in the mathematics of fractions, in what one gets to learn from the fractions, okay? In the mathematics of fraction. Okay, we're gonna explore this. We're gonna explore is fractal patterns and compound interest in the mathematics of fractions. Okay, so things started to make sense. So this course is all about learning to see math in new ways. Okay, so we're gonna see is this two specific topic: fractals, explore fractal patterns and compound interest in the mathematics of fractions. Okay, so by visualizing fractions less than 1, okay, so by visualizing fractions less than 1, we'll learn about a beautiful mathematical pattern called fractals. And while visualizing greater than 1, so by visualizing fractions greater than 1, will reveal the exponential growth of compound interest. Eventually, we'll get to the elephant in the room. So the whole point of looking at by visualizing is fraction less than 1, especially using a triangle, okay? Okay. So by visualizing fractions less than 1, we'll learn about beautiful patterns called fractals. Okay, so we look at this particular triangle here, and how by looking at fractions less than 1, all right, so for example, how we can represent is for example, a fraction here, 3/4, like this. And how can we represent now a fraction of a fraction, okay, in this visualization? So how can we represent is 3/4 per 3/4? In this visualization is again, it's taking a triangle per each side, like this. So by looking at this particular fraction, by looking at this particular patterns here in the mathematical fraction less than 1, okay, we look at something called is the Sierpinski fractals, which is how a triangle is made out of triangles. So this is one concept, okay, and especially this is something useful and good if you want to create your life. So if you assign each one of those triangles to areas in your life, how you can now dedicate your life to things that really matter. So for example, here you say, hey, I would like to dedicate now time to relationship here, money, and health. All right, in this triangle. And now from each one of them you can say, all right, how can I now divide my time here? So for example, I can see family members or colleagues, other people. And when it comes to money, it's like, okay, what is the problem that I need to solve? It's like, well, I need income. I need to keep track of my finance. And also I need to still learning about business and the economy and finance, okay? And when it comes to health, so okay, so where I'm going to dedicate my time and energy. So for example, in the by learning about fitness and actually do the work, so hit the gym and improve my nutrition and diet. Okay, so things started to make a little sense. So now if you go even further that you can now have much more even finer control about it. So if you want to explain that to someone else with 3/4, okay, or with a triangle, this is a beautiful way to say, hey, where are you want to allocate your time and energy? And uh, and looking at this is something beautiful. Mhm. So as you study more math, you will notice that beautiful pattern and insight away behind every corner. Next, we're going to see a different side of to fraction. This time, by consider a fraction greater than 1. Okay, 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 no, go back. That's right. Here we are. So all of this was to consider the mathematical fractions less than 1 and how a particular pattern occurs, for example, called fractals. Specifically, using visualizations using the triangle to now explain patterns like Sierpinski fractals, okay? Or Sierpinski triangle, which is a fractal, a pattern of fraction less than 0. Okay, okay, okay. So what is the value proposition here? What is the value proposition here of looking at this? Okay, so the value proposition, the value fractals, value proposition. Okay, a pattern, a pattern, a pattern that arises. Exactly, a pattern that arises for a pattern that arises exactly a pattern that arises from fractions less than 1. Okay, so value proposition, a pattern that arises from fractions less than 1. How can you apply this to your life? That's the question. So, okay, now that I know this pattern, how can I apply that? It's like, how can I do something with that? Because it's okay, it's cool to know something, but if you can't apply that, the question is that, are you even smart enough? What you gonna do with that? It's like, great. It's like knowing that. It's like knowing that. Uh, it's like knowing that. Okay. Outlet. Really. Uh, Electric outlet, I will say. Hmm. Okay. 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 All right. Outlet. So it's like that the outlet. If you know, so knowing this pattern is like that the outlet on your house can kill you if you insert some metallic stuff in there. You're gonna get electrocuted and rip. So if you know that, but yet still you do that, there is an outcome, there is a result of that. So, but once you know something, uh, uh, once you know something and you know how to do that, that is something that you shouldn't do anything close to that. That's the value proposition here, especially when you know something. It's like, I'm going to learn this so I can, so I, so, so I'm going to learn that if I get my fingers close to an outlet, a house outlet, I'm gonna get electrocuted and gonna die. So, so once I know that, the question is, are you gonna do that or not? Most of the time, it's not. Am I right? Most of the time, it's not. Another example is like, um, uh, okay, okay. Um, Once you know how to send, okay. So another example is that you know how to send posts in Instagram, okay. So what you're gonna do with that knowledge? If you don't do anything, it's like the knowledge is still there. Another good example is that hitting the gym. You know that hitting the gym is something good for you and for your health and for your overall feeling. All right, but yet, you're still not doing that, my friend. So what you gonna do? So knowing something is not a guarantee of actually get something from it if you don't put a practice. So the TLDR is that I'm going to put a practice what I'm learning from here. And the way to do that is, well, here, fractals, value proposition, a pattern that arrives from fraction less than 1. How can I apply this? How can I apply this to your life? Okay. Uh, you can set, okay, Set goals. Set goals in your life. Set goals in your life. So this is the triangle draw. Okay. Triangle draw. What you have at the top is relationships, business, and health. Okay. Relationship, business, and health. Relationship, business, and health. Okay. That's the first triangle. Set goal in your life. Set goal in your life. And once you can refine, exactly, set goal in your life. Refine how you gonna do that for clarity. And here in the relationship, you have relationships, relationship portion, relation triangle portion. Okay, relationship triangle portion. How you're gonna do that for clarity and outcome. Refine how you're gonna do that for clarity and outcome. Relationship triangle for clarity and outcome. And outcome. So refine how you're gonna do that for clarity and outcome. Relationship triangle portion. Okay, relationship triangle portion. So first you're gonna have is now the relationship. So family. Refine how you gonna invest your time for clarity and outcome. So relationship triangle portion. So family, friends, and mentors. You know, relationship triangle portion in this case is business triangle portion. So here is a you say career. Okay. Exactly. Family, friends, mentors, business triangle portion, career. Exactly. Business triangle portion, career, finance. Okay. Career, finance, and investment. All right. And the other is And the other is the health. So here is fitness, nutrition, okay, fitness, nutrition, and meditation. So this is the value proposition, a pattern that arises from fractal less than one, and how you can apply this to your life. Set goal in your life, triangle draw, relationships, business, and health. Refine how you're going to invest your time for clarity and outcome. Relationship triangle portion. Family, friends, and mentors. Business triangle portion. Career, finance, and investment. Health, fitness, nutrition, and meditation. So this is slide one. Exactly. This is slide one. Slide one. Slide one. And then slide two. Slide three. And slide four. Right. Knowledge is not power. What you can do with such knowledge is not power. What you can do with such knowledge is where, what you can do with such knowledge is where, exactly. So what you can do with such knowledge, that's something else entirely different. What you can do with such knowledge is when things get interesting. Knowledge is not power. What you can do with such knowledge, is when things get interesting. This triangle is known as, so this pattern is known as Sears, holy shit, Jesus, Pinsky. Holy shit. Warkla Sierpiński. A Polish. Oh my god. All hail, man. Jesus Christ, nigga. Jesus Christ, nigga. Jesus. Warkla Sierpiński. How do you pronunciate that N with this? Like, Warkla Sierpiński. I thought it is. Well, anyway. But yeah, Sierpinski. Sierpinski. This pattern is known as the Sierpinski triangle. Once you learn something, exactly, once you learn something, so knowledge is not power. What you can do with such knowledge is when things get interesting. And this is what I'm going to do. This pattern is known as the Sierpinski triangle. So that's right, my friend. That's exactly what I'm gonna do here in today's video. It's all about that. So that'll be all for this video. Take care. Bye bye.